everybody uses in their daily lives, but don't think much about. Coding and codes. This is presented by Abhiram Dasri, Harvit Kola, and Srithan Surpaneni.
Hi all, my name is Harvit Kola, and I'm a rising 8th grader at TMSA.
My name is Abhiram Dasri. I'm a rising 8th grader at Carnage, and our partner Srithan Surpaneni unfortunately couldn't be here, but he did contribute to this slide.
I know most of you out there are coders, but we wanted to present our perspective on coding. Next slide, please.
All right, but first, some background knowledge. So the definition of code is assigning a code to something for the purposes of classification or identification. I know, it sounds complicated. It really isn't. So a coding language is a series of commands or syntax used to create that code. So code is assigning something to something so you can identify it, and a coding language is making code out of commands. Pretty easy. Some examples, just JavaScript, Visual Basic, Python, all the ones that you've already heard. I'm sure all of you have already heard of these languages. But there are 5 types of main languages. There are procedural, functional, object-oriented scripting, and logic. But it's important to recognize that most of these languages are in more than one of these groups.
So the first type of languages, procedural coding, are used to execute a sequence of statements. One example of this is Pascal. They use loops, variables, differentials, and many other elements. The second type, functional languages, don't use loops. Instead, they use recursive functions. They use stored data. They convert the code into binary to feed into the machine. One example of this is Perl.
So the third type that we are talking about is object-oriented. So they view the code as a group of objects with different characteristics. So you would code the different objects and define their different characteristics. Now they emphasize reusability and they fit a lot of code into a small space. So they're good for more visual programs. So an example of this would be JavaScript. And the fourth type is scripting languages, and they're not really full-fledged languages on their own. They're more of a basis for a larger type of code. They usually require a syntax in order to start, and they include languages like PHP.
The fifth and final type of coding is logic. They make a statement and let the computer do the work all by itself. They tell the computer what it can't do, not what it can do. Next slide.
So let's say you wanted to code something. First, obviously, you have to choose what you want to code. So this can range from anything like the code using an MRI scan to just a simple website. So let's say you wanted to code a game. I know a lot of you probably play games. You're teenagers, like me. So what you would want to do is first pick a language, pick different types of code that you want to use in your game, learn the different types of code, their formatting, when to implement them, and how they work, and then just code the game to the best of your abilities. Now, it's important to recognize that as you keep learning more code, you have to keep adding to your game. So once you think it's complete, then just keep on adding more, and eventually you probably want to play your game. Which brings us to our next step, running your code.
So after you've written your code, you have to run it, test it out, and even play your game. Running your code is quite simple. Most compilers have a run button, which allow you to test the code and see the visual product on screen. But while you're running your code, keep an eye out for errors and bugs. These can impact your game in a detrimental way. The next step, we will learn how to deal with these errors.
So now that you've found the errors in your code, obviously you need to fix them, unless you don't want to and you abandon the whole thing, which is not good. So just identify where and why your code is going wrong and how you can fix it. So this would, in our example, if we're building a game, this would be the beta testing phase. So users would give us feedbacks, they would point out bugs that we have to fix, and we would fix them. So after you're done with this phase, you're basically done with your game. But it's important to recognize that your work as a coder is never really over. You can keep on adding to the game, and you can always make a new one. Keep on learning new languages, implementing them in different ways, and adding to your portfolio to be the best coder that you can be. Thank you for your time.